Hello everyone, welcome to my class. I'm Dr.P.Ganesh. Today in this class we are going to discuss about the various network connecting devices. So in this various networking connecting devices, we all know that there are many networks are available. In that networks which consist of host as well as the networking devices. So there are various networking devices which is available as like bridges, hubs, switchers, and then the routers. So now we can see that what are all the networking devices majorly which is used and where this networking devices fit into that OSI and TCP reference model, and then we will see that functions of that. So the networking devices, these are all the connecting devices of the end host, or either it may be any type of node, the host as well as and the networks. So here the internet, automatically it means that there are two types of networks we can able to create, either the internet which mentioned in small I, local internet, and then capital internet, capital I, mentioning that the worldwide internet. So whatever it may be, either it is going to be a local network or it may be a worldwide internet, which is going to connect all the host and network, which is going to operate in a different layers of the OSI as well as the TCP IP model. It is not only all the networking devices which is going to operate in only the physical layer or only the data link layer or the network layer. So in major, we are going to discuss here, there are three types of devices, connecting devices, which are all hubs, link layer switches, and the routers. Apart from that, there are some gateways also there. The gateways are called it as then protocol converters, which is going to operate right from all the 7 layers. It means that right from application to the physical layer, it is going to be a protocol converters. Majorly, these gateway converters are going to be in the form of software in nature. So the below diagram, you can see that the various types of network devices. So you can see that routers, switchers, hubs, bridges. If you want to connect 2-3 LAN networks, you can use for bridges, and the gateways, as I said, which is going to be in protocol converters, routers, which is going to work for all the 3 layers. It's starting from the physical, data link, and the network layer, and then access points. We know that the access points, which is majorly we were using it in our wireless local area network, which is also going to be operated in both the physical as well as the data link layer. And the hubs are going to be used in only the physical layers. And the best example is repeaters, and then switches, link layer switches, which is going to operate both in a physical as well as the data link layers. Now in this diagram, we simply compare with an OSI reference model. So in this OSI reference model, we know that it starts from the application layer to the physical layer. So the each layer functions also has been given. The application is an user interface, and then a presentation is a data presentation, encryption, compression, and encoding. And for a session, maintaining the sessions, the transport is a process-to-process communication and the port numbers assigning it. And then the network is a logical addressing, source to destination delivery, and the data link layer is a physical addressing, node to node delivery, and then physical layer is going to be movements of bits between the devices. So here what it mentioned is, from the application to that the session, it is all going to be in the form of datas. And then when it comes to a transport, it is in the form of segments. In network, it is in the form of packets. Data link layer, it is in the form of frames, and the physical, it is in the form of bits. Now, so from application to all the physical layers, the gateways are going to be built. There is only one protocol networking devices, the gateways, which are all the protocol converters, which is going to operate in all the 7 layers. Apart from that, if you see that the major networking devices, hardware networking devices, are the hubs and repeaters, which is going to be used in the physical layer. So whatever the hubs and the repeaters, it will work on only the physical layers. And then the link layer switches and bridges, which is going to operate in both physical as well as the data link layer. and then the routers which is going to operate on all the bottom three layers, all the network oriented layers starting from physical, data link and the network layer. That is what it is given in this picture. Now let us start with hubs. We will start with the physical layer device. It is one of the best example for the physical layer device, the hubs and repeaters. This is going to operate in physical layer, so which is going to handle the movements of bits. So here only the data are going to be converted into signals. So by default, these signals are going to be the carry the data or the information either within the network or across the multiple networks. So the travel of fixed distance, which can able to carry the signals in the form of data in the form of signals, which is going to be traveled for a fixed distance before it is getting attenuation, which endangers the integrity of the data. We all know that if it is going to be a guided media, then the guided media may be in the form of electric signals, maybe 0 to 5 volts. So if that particular signals can travel for up to some distances, after the distance the signals may get attenuated. So because of that, there is a chance for error and we may loss of the data. So definitely we require a device. This physical layer devices has to regenerate the signal strength. It means that the repeaters, the best example is in repeater. Repeaters receives a signal, and before it becomes too weak, before it gets attenuated to that next level, or it may be a corrupted, which is going to regenerate into an original form and retimes the original bit pattern, so that the signal can, for every fixed distance of interval, we used to place in a repeaters, which that repeaters is going to regenerate the signal strength and retimes it, so that the signal bit can able to travel for a longer distance. The below diagram, you could able to see that how the hub is working. If you see that the first device which is also sending an data, and what it is going to happen is it is in a broadcast in nature. Hubs will be working in the broadcast in nature. So what it is going to do is, whichever the sending station which is going to broadcast into all the stations, so all the stations are going to receive the data. Whichever the device is which contains a destination address, whichever, suppose if I am getting a signal, if the destination address is to my original address, then I will take it, I will retain that value, I will retain that data. So remaining all other systems, simply it can discard that packets, discard that information. This is how the hubs are going to work. Now in this diagram, you could understand this concept very clearly. Now we have considered one hub with the 4 devices, 4 systems are connected, which is name it as an A, B, C and D. Now A is sending an data. A is going to send a data. Now this is going to, data is going to send to hub. So B is a designated receiver. So only the B is going to receive that data. Remaining all other devices also going to receive the same information, but that devices are simply which is going to discard that information. Only designated receiver alone who is going to receive the data is going to have a copy of it. Remaining all other systems simply which is going to discard it. So this is what the hub. So what is a major drawback is, at a time only one device can able to send a data. So remaining all other systems can't able to send a data, and which is going to occupy a huge bandwidth and waste of network resources. That is the reason we will be moving into a next level link layer switches, which is going to operate in both the physical as well as the data link layer. It is up to that. It is when compared to the hubs, it is going to the next level of networking devices. So the physical layer functions as if how the hubs are going to work the same way, which is going to regenerate the signal and retimes the signal. As like a link layer devices, the major functionality is going to be physical addressing. So it must have an checking of an MAC addresses. It means the source and destination MAC addresses, which is going to be contained in the frames. So that is what the function of link layer switches. So the below picture, below diagram, which explains that animations of how the switch is going to work. Now you can see that at a time the two devices, each device is connected to one port of an switch. So the first system may send a data to fourth system or the seventh system. At the same time, the second system also can able to send a data to fourth system. Similarly, we can send a multiple datas. So up to that maximum capacity, it can able to use it. When compared to the hub, it is going to be a greater advantage of using a link layer switches. Now we can see that there are different types of switches also going to be there. So first of all, it must know that the port numbers. We already discussed about in our earlier class what is the format of a MAC address. So this is how the MAC address format is going to be. So from this also we can understand how the transfer modes. It means that what type of address it belongs to. Either it is going to be a unicast address, multicast address, or it is going to be a broadcasting address. Now in this example, you can see that this is a switching table. So the port 1 is connected to this device, that particular device, the MAC address. Similarly, the port 2, 3 and 4. The same way which is going to maintain a switching table. Next one is, now there's first system sending a message and the second device is going to be a designated receiver. Based on that the MAC address, immediately it can forward the packets to only the designated systems. It is not mandatory to forward all the packets to all other systems, but there are some possibilities. If that particular switch doesn't know about which device has been connected to that particular network, then it can learn the things, learning of switching table. That is what learning switch. So in this learning switch, what it is going to be, the same 4 devices are going to be connected to a single switch, but at the initial stage there is no entry. There is no entry of the switching table. So the switching table is going to be an empty. So what it is going to do be, how it is going to build a switching table is, because we may change the number of devices, we may increase the devices, we may decrease our devices. So it has to be update the routing table, it has to be update the switching table so that it can able to forward the information to the designated destination. Now you can see that in this example, the first initially the address and ports are, it is going to be an empty. Now A is sending a data to D. So immediately the switch can have an address of both A's MAC address as well as the port number. Then D is sending an information to B. Now the switching table can able to get an D device, the MAC address, as well as the D device can be connected to which port. Similarly, after B is sending some information to some A, then immediately now the switching table which contains an information of both A, B and D. And then once the after C is sending some information to any other devices, then the entire switching table which contains all the devices, the MAC address as well as the port address. This is how the learning switch continuously it is going to learn the MAC addresses as well as it supports. So this is the way it can able to build a routing switching tables in the switches. Now there is one problem, loop problem in a learning switch. If you are considering it's a very complex network, it means that multiple switches are going to be there in the single LAN network. In that cases, there is a possibility of looping. Now we can see that how the looping problem is there. Now this is a structure we are considering LAN 1 and LAN 2. This LAN 1 and LAN 2 which has been connected via the 2 switches, the switch 1 as well as the switch 2. Now LAN 1, A wants to send the data to D. So there is a possibility for sending an data to both the switches. So it can send a copies to both the switches. Now both switches forward the frame. Then at the receiver side, the 2 copies of the frame is going to be received in the LAN 2. This is what a looping problem. The same way, the D when it is going to send both the D is sending to data to back to an A, then both the switches which is going to forward the data, the same way the A is also getting a 2 copies of a frame in a LAN network. This is what we call it as an looping problem. It means that the same data can be received in a multiple times. Loop problem in a learning switch. So automatically both the switches going to learn both the LAN 1 as well as the LAN 2, the routing table, switching table information as well as the port informations. So this we call it as a looping problem. Next is we can see that how it is going to calculate the shortest path. So once the looping problem occurs, it is the need of the hour to resolve this issue that can be solved with the help of some graphical method. Now we can consider that a system of connected LANs and its graph. Now in this diagram we are going to consider the system 1, S1, S2, S3, S4. The same way LAN 1, LAN 2, LAN 3 and LAN 4. So these are all the 4 LAN networks are going to be connected. So here a system of connected LANs and graphs with the cost we are going to do that. So what we are going to do is from whenever the system is sending a data to any other LAN network, the cost will be taken as a 1. Whenever the data comes from the LAN network to the system, the cost is going to be considered as a 0. So this is where which can able to calculate the distance to reach from one network to the another network, from one system to the another system. So now we can see that the system 1 can able to reach the LAN 3 with the cost of 2 via the LAN 1 and LAN 3. Whereas if it is going to travel in another way, there may be some cost may be increased. For example, S1 to LAN 2 and then LAN 2 to S3 and then S3 to LAN 3, and then if it is going to reach S5, then the cost is going to be 4. So in this way it can able to avoid the looping issues in the switches. So here the finding the shortest path. Now we are going to consider that S1 is going to be a root node. So for each node which is going to calculate the shortest path. So S1 can able to reach a LAN 1 with the cost is 1, and then it can able to reach the LAN 3 with the cost is 2, and the LAN 2 it can able to reach it with the cost 1. So the S3 also can be reached with the cost is 1, and S4 is also cost 1, and S5 and LAN 4 is also cost 2. So this S1 node can able to reach all other LAN networks as well as all other LAN network systems with a lesser cost of with 1 and maximum of 2. This is the shortest path. So in this path itself, which is going to decide that which are all the paths does not exist, that also going to be given in that spanning tree algorithm. Now in this diagram you can see that from S3 port 2 and S3 port 3 is completely blocked, as well as S5 port number 1 is completely blocked. So these 3 routes are not permittable for S1. So this is where we can able to avoid the looping issues in the switchings. Now we can see that the routers are 3-layer devices, because which is going to operate both physical, data link and the network layers. All the 3 layers which is going to operate. For example, below that diagram you can see that there is one common router is going to be there. If we see that 10 gigabit LAN network, wired LAN networks. So already we have discussed detail in the earlier classes in the wired LAN networks, wired Ethernet. There we have discussed about the 10 gigabit LAN networks. So via that 10 gigabit LAN networks, there are 2 LAN networks are going to be connected. So internally there may be many switches and hubs are going to be used. All that traffics are going to reach that router, so that via this router the external traffic is going to be. Suppose this LAN network to any other data wants to move to some other network, so via the router it can able to move. That means that which must have both a physical data link as well as the network layer addresses. Now this picture simply it shows that. Let me recap that all these 3 important networking devices. Majorly for a physical layer we discussed about the hubs, and the data link layer we have discussed about the link layered switches, and for network layer bottom 3 layers we discussed about the routers. So in this hub we understood very clearly, it is going to be in a broadcast in nature. Suppose you see that any one system wants to send a data which is going to broadcast to all other systems in that. So which is going to by default wasting of network resources as well as unnecessary traffic which is going to be occurred in that network. And also the main functionality is going to regenerate the signal strength before it get attenuated or the corrupted, and also retime the bit pattern so that it can be able to travel for a longer distance. This is what the hub, which is going to operate in the only the physical layer. Next, we have discussed about the switches which is operating in the link layer. Up to that data link layer, it means that both it is going to operate in the physical layer function as well as the data link layer functions. It means that the physical layer hub, how it is going to operate, which is then regenerating the signal strength, retiming it, all that functions which is going to perform in the switch, and also based on that devices which is going to designated devices going to connected in the port, based on that which is going to forward it to the only the designated nodes alone. So that is where the switch is going to work when compared to hub, which is having a greater advantage. At last, here in this diagram you can understand that this network we call it as a red network. For example, we have name it as this 4 devices which is connected to one switch or hub, which we call it as one red network. We can call this red network. So this hub is or switch is connected to our router. So the router may handle the very multiple network data. Say for example, other networks by easy to understanding, some yellow network, red network, green network, and then fluorescent network. So all the packets which is going to come into that router. So the router which is going to see the addresses which are all the packets belongs to that particular network, this red network. Only that packets alone has to be forwarded to that local switch or hub. So based on that which is going to operate, so which needs to operate both in the physical data link as well as the network layer functionality going to perform in the routers. Apart from that, some gateway converters are there. This gateway converters which is going to operate right from application to the physical layer. It means that all the 7 layers which is going to work, simply we call it as a protocol converters. I hope you understand the concept of network connecting devices, in which layer it is going to operate and how it is going to operate. If you have any doubts, you can write it in the comment line. I'm happy to respond to your questions. Thank you for watching my class. If you don't subscribe to my channel, please subscribe to my channel. Have a great day. Thank you.